Alright, so now your simulation has finished running. I'll show you what to do now to compile the results and look at them. So here's our folder where we had everything, and then as I said, the simulation is going to create a folder that's called number prox case, indicating how many processors that you used, and all the results are going to be stored here. So let's take a look at what's in here. See, all these restart files are where all the results are stored. So for each time step that you've saved the results, you will get a set of restart files that contain the results that are calculated from each processor that you used. So what we want to do is we want to combine these different files from the different processors into one file that we can look at. And we're going to do that using SymVascular. So since everything is on Vivian, I'm going to log into Vivian to do this. And the way that I'm going to log in is I'm going to add in this flag, it's minus capital X here, to log into Vivian. And you need this because we're going to be launching SymVascular from Vivian, and the minus capital X allows the X tunnel, which means you're able to use a graphical interface. So you need this. Going to go to my my folder. So here's where all the restart files are. And then I'm going to start SymVascular. Okay. And then I'm going to go to Simulations, Solver to Vis files. And this is where you would convert the restart files into the files that you need. So this is a start time step. Since I ran 6,000 time steps, I'm just going to convert a couple files here. So let's say I want to start at time step 5,000, and I'm going to stop at, I'm just going to do a couple because otherwise it's going to take a long time. And here you specify the increment, which means, remember in our simulation we saved every 20 time steps. So if you want to convert all the files, then you can put 20 here. I'm gonna put 100. I'm not gonna convert all of them, just to make it faster. And so that's all you have to set. And then once you do that, you click both. When you click both, that means it's creating, for each time step, it's creating two files. One is called the vis file, one is called the VTU file. The vis file is a file format that's used by SymVascular that contains all the essential informations. We don't really use this to visualize, but these files are important because if you want to relaunch the simulation from a time step, you could get everything you need from the vis file because it contains all the results. And then once SymVascular creates the vis file, then it will go ahead, based on the information here, create VTU files, which you can use to look at the 3D results in ParaView, which I will show you how to do later. But anyway, this is all you have to do here, and then once it's stopped converting, you can just quit SymVascular, and you don't need this anymore. And so let's look at what we've created here. So what we've done in SymVascular has created these 4 files. And so I'm just going to copy the files that I want from to my computer. And so the important files that you want are the VTU files, and then all data, and then anything that ends with general. So here's eGeneral, there's pGeneral and qGeneral. And it's also a good idea to just copy hyster as well. These are the essential information that you want to save for the results. Okay, so I've got these on my computer now, and I'll show you what these files are. And so the old data file contains columns that tell you what the values are for each of the x variables in the genbc or in the user.f file that we modified before. And so it just shows you what the values are for each of the x's at every time step. So that's the old data file. And then in the general files, so the old data is generated by the genbc program. So this is essentially all the boundary condition stuff. But in our case, we didn't really do any calculations there, and that's why it's so boring here. But if you had a complicated network that you're solving for the 0D domain, then you could potentially have a lot of variables that you're solving, and then so this file will provide you with the information of what the values are for those variables across the time steps. And so that's the 0D domain stuff. And then the general file, these files contain information about the boundary, things that are happening at the boundary, and these are generated by the 3D domain code. And so let's just look at the QGeneral here. So this is flow information across the different outlets, and so the first row tells you what the outlet IDs are, and so that you know which row or which column corresponds to which outlet surface. And then these are just the values of the flow rate at all the time steps. And just one thing to note is that in SymVascular, flow rates that are negative means the flow is going into the model, and then positive flow means any flow that's going out of the model, and that's why you have the negative and positive here. And so this whole row here, all the rows should add up to pretty close to 0 because you have mass conservation. And then the same idea with the pgeneral. This tells you pressure information at all the different outlets, and then remember, these are in whatever unit that your simulation is running, and so these are in CGS units, so these are not in millimeter mercury. So if you want that, you have to do that conversion yourself. And then the eGeneral, it's the same idea. It just tells you what the energy flux is through the different outlets. And so that's what these files are used for. And then in a different video, the next video, I'll show you how to look at these VTU files in ParaView.